So 20 times 9, 180. Then plus half. Then 12 into 81. So 12 times 81 is 972. Then half plus 180. So 972 divided by 2, that is 486 plus 180. So 486 plus 180. This is S9 is going to be 666. So therefore displacement covered in the 9th second. The 9th second is equals to that is that of meter, that of S9 minus S8, which is the sentinel saying 666 minus 544. 666 minus 544. So 122 meter. That's my final answer. That's the final answer. So let's move to question 15. Acceleration of a particle in a time t is given by the equation a equals to 2 plus 5t square. Find the instantaneous velocity after 3 seconds. Question 15. Remember I told you from acceleration you are going down. So from acceleration going down, you integrate. Remember I gave you displacement, velocity, acceleration. So when you are going this way is differentiation, but when you are going in this opposite direction you integrate. So going this way you integrate. So let's integrate. We are given a equals to 2 plus 5t square. Acceleration of a particle. So question 15. A equals to 2 plus 5t square. So all I need to do at this point is I integrate. So v is equals to, notice integration means when you have a constant you add a variable to it, and the variable here is t. We are integrating with respect to t. So plus, notice that integration is opposite of differentiation. I have 5t square. So the rule is simply in differentiation you will multiply before you subtract, but in integration you will add, then you divide with the new power. So this is now 2t plus 5t cube all over 3. So this is what you have for v. So at 3 seconds, 3 seconds, you now have that this is the sentence saying v is equals to 2 into 3 plus 5 into 3 raised to power 3 all over 3. And this is the sentence saying, hello, this is the sentence saying 6 plus 5 into 27 all over 3. Oh yeah, 5 times 27. This is the sentence saying 135 all over 3 plus 6. So let's do 135 divided by 3. So we get 6 plus 45, which is equals to 51 meter per second. So this is our v in 3 seconds. So let's move to question 16. 16 says the distance covered by a car. The distance covered by a car, question 16, at a time t is given by 20t plus 6t raised to power 4. Calculate the instantaneous velocity and acceleration when t equals to 1. Notice that this is like we are at distance, or we call it this way, we are moving this way, so we differentiate. So from small to big, differentiate. Big to small, integrate. So 16. X is given by 20t plus 6t4. So for velocity now, we differentiate. So this will be the same thing as saying 20. Then t now has an invisible 1 here. Times this is still 20. So 1 minus 1. Remember, we always subtract from the power. Plus this 4 times this 6. 24 t, then 4 minus 1. So this is the same thing as saying t raised to power 0, and anything raised to power 0 is the same thing as 1. 20 times 1 is 20 plus 24 raised to power, that is t raised to power 3. So this is our v. This is our v, and they say we should calculate velocity when t is equals to 1. So at t equals to 1 seconds, at t equals to 1 seconds, we have that v is equals to 20 plus 24 into 1 raised to power 3. And this is the same thing as saying 20 plus 24. 1 raised to anything is 1. So this is the same thing as saying 44 meters per second. So to get acceleration, simply differentiate distance 2 times, or you just differentiate the velocity. So since we have that v, since v equals to 20 plus 24 t cube, acceleration now will simply be differentiating to constant is 0. So we have 24 t cube. So 3 times, we just, you see it, we use the power to times the coefficient. So this is now in such a way that we now use the power, that is 3 times 24, you get 72. Then t, the power, subtract 1 from it, so you get 72 t raised to power 2. That is your A. And remember that at t equals to 1 seconds, A will now be equals to 72 into 1 raised to power 2. And anything raised to power 1 is that. So A is equals to 72 meters per second square. Very simple. So let's move to the last one, number 17. A ball is thrown upward with initial velocity of 40 meters per second. Find the time it takes the ball to reach its highest point. Find the distance. Find also the distance to this highest point. So see, they said, let's just bring out everything they have said. So they said that a ball, question 17, a ball is thrown upward. When you are going upward, it's no longer horizontal motion, or this time around is now motion due to gravity. So at this point, acceleration due to gravity, when it's coming down, is the normal thing, is positive, g is positive, but at this point you have minus g. So g, you have minus 9.8 or minus 10 meters per second square. You need to note it, that's the first thing. Now they gave us velocity to be 40 meters per second. And they say it's the initial one. Now, the ball is thrown upward. So whenever something is thrown upward, v is 0. Final velocity is 0. But when that, because if it reaches the highest point, there will be no velocity at that final point. But when they say something is thrown to the ground, if that thing hits the ground, it will take some direction, maybe right, left, or however it is. So when they say something is thrown up, v, final velocity is 0. But when they say something is thrown down, initial velocity is 0. So I get my v to be equals to 0. And they said find the time it takes the ball to reach its highest point. Okay, that is time to reach its highest point, t, small t, I don't know it. Okay, find also the distance to this point. Okay, distance, I need to find it too. So all I need to do is, since I have u, I have v, and a, which is g, is a constant. So let me use the second equation of motion, which is v equals to u plus at. And in this case, v equals to u minus gt. So it becomes minus. So all I need to do is, this is 0 equals to 40 minus 9.8 t. So, and t is what I'm looking for. So all I need to do is let the 40 cross equality sign, because minus 40 is equals to minus 9.8 t. Minus minus cancel. So that you divide both sides by the coefficient of t, which is 9.8. So t is equals to just 4. We say 3 points. So now 40 divided by 9.8. So you get 4.082, which is approximately 4 seconds. Okay, now find also the distance to this height. The distance, I will say displacement. So let's just apply our formula for anything distance. So I will simply make use of s to be equals to ut, okay, plus, I'm coming, half at square. I want to check something. Do I have a? I don't have a. Okay, but my a is constant. It's a constant, so I can use this. But okay, yes, because at that highest point, v is 0. V is 0. I can also use v square equals to u square plus 2as. Okay, I'll make this a subject of. Let me just use this. So h, which is this, is equals to u here is 40. T is 4 minus half. G here is 9.8 and t is 4 square. So let's check the distance at this highest point. Okay, let's go. The distance. So I now have that this is the sentence saying 40 times 4. I have 1/6 minus half 9.8 into 16. So 9.8 times 16 is 156.8 all over 2 minus 160. So divided by 2. So 156.8 divided by 2. I have 78.4 minus 160. 160 minus 78.4. So I get 81.6 meter. So at my find also the distance to this highest point. So the distance to this highest point, that is the, if you are talking about distance to the highest point, that is the maximum height. So this is my answer. It's 1.6 meter. But they said we should take G to be 10 meter per second square. I didn't even see that. So when you're solving yours, you use G to be 10 instead of 9.8. So that is that.